So that was our answer. That one's more concentrated, the molarity. Okay. Next problem says the gases in a hairspray can are at a temperature of 27 degrees Celsius and a pressure of 30 psi, pounds per square inch. If the gases in the can reach a pressure of 90 psi, the can will explode. To what temperature must the gas be raised in order for the can to explode? Assume constant volume. That's key there. So I love this type of review. I've not told you what equation to use for this problem. But let's go in and label what we have. We're given an initial temperature. I'm going to label this as T1. 27 degrees Celsius is T1. And we're given an initial pressure, this right here in PSI. We'll call this P1. And it says if the gases can reach a pressure of 90 psi, we're given a second pressure. I'll call that P2. It says to what temperature, this is asking us to solve for T2 and constant volume. So this is a combined gas law problem where we have, wrong variable. P1, V1, I'm all over the place today, over T1 equals P2 V2 over T2. But remember, if we have constant volume, volume goes away. We remove it from the equation. So here's the equation we should use to solve this problem. So we have P1 and P2, and we have T1. We're going to solve for T2. If we are solving for T2, which is in the denominator, you can do a lot of algebra to rearrange the problem. I like to, when I'm solving for something in the denominator, here T2 is in the denominator, I'm just going to flip the whole equation. I'm going to take the reciprocal of my whole equation. Okay, I want my temperatures to be on the top when I solve for temperature. So when you flip the whole equation, you get this. And this is legal. The math works out just the same as if you did a whole bunch of cross multiplying and dividing. Okay, so now T2 is in the top. We need to isolate T2, so I'm going to multiply both sides by P2. I should have written P1 here. There we go. I'll just write it over here, times P2. Okay. So now these cancel out. Our equation is T1 times P2 divided by P1 equals T2. So this is the equation we're going to use to solve this problem. The only other stipulation here is that temperature needs to be in Kelvin. So we're going to convert our temperature to Kelvin. We see that both P1 and P2 are same units, so that's good. We don't have to do any other conversions. If it gave you a unit of like ATM over here and PSI, for P2, you would have to convert the pressures to make sure they're same units, but we already have same units on pressure, so we don't have to do any added conversions there. The only thing we need to do is convert 27 degrees Celsius to Kelvin. Hopefully this is something you can do in your sleep by now. And so that gives us 300.15 Kelvin. All right, now and this is our new T1 temperature. Okay, so T2 equals, I'm just using this equation down here and plugging everything in. T2 equals T1, which is 300.15 Kelvin, times P2, which is 90 psi from our problem, divided by P1, which is 30 psi. And it says, to what temperature must the gases be raised? So I would anticipate here that our second temperature that we're solving for will be higher than our first, higher than 300.15 Kelvin. So 300.15 times 90, And then we're going to divide that by 30. Second temperature here is 945 Kelvin. That's very high temperature. Okay, but that's our answer. Okay, we will continue with the next problem. Oh, we already did this one. It's a repeat. So since we already did it, I'm gonna skip